Okay, so this is the second video in the college algebra series. It is titled Circles. Let us begin now. The distance formula is the basis of the circle equation. A circle is a set of points in a plane that are at a fixed distance r, called the radius, from a fixed point h, k, called the center. Let me zoom into this figure here. On the left here, we have a circle. This is the center. And the distance from the center to the edge of the circle is called the radius. So this here is the center. And this here is the radius. Okay. So if you recall from the last video, we had 2 points. Let us call them A, B. Join them. The coordinates of this point would be x1, y1 and x2, y2. The distance formula is square root of x2 minus x1 square plus y2 minus y1 square. So we are going to use the same formula to find the equation of this circle here. Here, as you see, this center is at the origin. So basically, one point, that is h, k, at least for this figure here, is centered at 0. So we can assume that the first point here is 0, 0. And let us just call the other point x, y, because now we don't have to worry about x1, y1, and all of those subcategories of x and y. So now, instead of x1, we just put a 0. Instead of y1, we have a 0. Instead of x2, we have an x. And instead of y2, we have a y. Then we square them and take the square root of them. So this is x squared plus y squared. Now, what are you saying? This is the distance formula. This is the distance between point 0, 0 and x, y. From the definition, that distance is r, which is the radius. So this is equal to r. So you can write this in another form where you just square on both sides. Then you get x squared plus y squared equals r squared. So this is our circle equation. Okay, let us do an example here. It says find the center of the radius of the circle and graph the circle. So here we have the circle equation is x squared plus y squared equals 9. We can just compare directly with the formula that we have here. So let us write down the formula again. We have x squared plus y squared equals r squared as one of the circle formula when the center is 0, 0. Then here in our question, we have x squared plus y squared equals 9. If we just compare this term by term, we have x squared as x squared, y squared as y squared, and then we see our r squared is 9. So r is root 9, which is both plus and minus 3. But here, for our purposes, we are calculating the distance, which is always positive. So radius is 3 units. So we have all the required information. We have our center as 0, 0, and our radius as 3. And that is more than enough to graph our circle. So now our circle center is 0, 0. And the radius is 3 units. The way I do is I just plot 3 points on all 4 directions here. There's one more and here. And then I just join them to get a sort of prettier looking circle. Doesn't really look like a circle, but that is a circle equation of this particular equation. Okay, let us do another one. We have find the center and radius of the circle and graph the circle x squared plus y squared equals 28. We do the same thing as last time. We first start writing x squared plus y squared equals r squared. And under it, we write our equation here. We have x squared plus y squared equals 28. And now when you compare each of these terms here, you have x squared as x squared, y squared as y squared, and r squared as 28. So r is root 28, which is, let me get my calculator here. So let's do square root of 28, which is 5.29. We will round it off to 5.3. And then we know that this is the equation when the center is 0, 0. So the center of this equation is also 0, 0. So this is our center, 5.3. So that's 1, 2, 3, 4, 5. A little after 5. 1, 2, 3, 4, 5. A little after 5. 3, 4, 5 here. 1, 2, 3, 4, 5, and here. And then we just join all our points here. And that is our circle equation with radius equals root 28. Okay. Next problem here we have is find the equation of the circle that is centered at 0, 0 and has the radius of 2 root 2. Let us write down our circle equation again. When the center is 0, 0, it is x squared plus y squared equals r squared. Here we are given that r is basically 2 root 2. So plugging in, we have x squared plus y squared as 2 root 2 whole square. Just a side note of how to solve this. This is basically 2 root 2 times 2 root 2, which is 2 times 2 times root 2 times root 2. So 2 times 2 is 4, and root 2 times root 2 is 2. So that is 8. So we have x squared plus y squared equals 8. That is our circle equation, which is centered at 0, 0 and has the radius 2 root 2. Okay, so far we've seen 3 examples where our center is always 0, 0. So here we have center 0, 0, here, and as well as here. But centers can also be centered elsewhere in the coordinate system. The center of the circle that is not centered at the origin is centered at a point h, k. There's just a general convention that you just call it h, k. This is basically like just us calling x1, y1 or x2, y2. So it's just a common practice where we call the center as h, k. Let us do the distance formula again, where we have 2 points, A and B, where A is h, k, and B is x, y. Now, if you want to find the distance between these 2 points, it's just square root of x minus h whole square plus y minus k whole square equals r. So it's x minus h whole square plus y minus k whole square equals r squared. So this is the equation of the circle where the center is h, k. As you can see here, that is the same thing where we did the distance formula here, where one of our points is x, y, and the other points is h, k. And then we square on both sides here, making it r square equals the thing that's inside the root. Okay, so when finding the center of the circle, we have to be careful of the signs. For example, let's do this where we have to find the center of the circle x minus 3 whole square plus y minus 1 whole square equals 16. Let us first try to solve this on our own and then look at the figure here. So we have x minus 3 whole square plus y minus 1 whole square equals 16. One thing, if you are doing this for the first time, I would definitely suggest that you have your formula always below things or above, just so that you can easily compare. This is h comma k here. So we have x minus h whole square, k whole square equals r squared. So if you compare line by line here, you see that h is 3 and k is 1. Sometimes we make these small mistakes where in a hurry, we think that h is minus 3 and k is minus 1. But if you closely look at the formula, it is minus h, and we want only h and only the k. That's why h is 3 and k is 1, and r square is 16. So r is root 16, which is technically plus or minus 4, but we only consider plus 4 since we are talking about the radius, which is distance, and it's always positive. Okay, so same thing here in this figure, just as a repeat here. So here we have a circle that the center is not at the origin, and then the equation is used at the standard form of the circle equation is used here. So as I said before, you compare term by term. Here h is 3, here our k is 1, and then we have r squared as 16. So this is the center here is 3 comma 1, and the radius is 4, and you can see it in the figure here. Okay, let us now do an example where we are using the standard form of the circle equation. Standard form is basically the form where you have h comma k instead of 0 comma 0, because now you can plug in any values of h comma k, any values of your center, which does not necessarily have to be 0 comma 0, but you can also use the 0 comma 0 because h comma k can be anything that you want on the Cartesian coordinate plane. Okay, so in this example, we want to find the center and the radius of the circle and graph it. Okay, let us first begin by writing the formula again. We have x minus h whole square plus y minus k whole square equals 9. Sorry, we're writing the formula first is r squared. Under this, we write our equation that we are trying to solve. It's x minus 4 whole square, y plus 2 whole square equals 9. So here we have x minus h is basically x minus 4, and we have y minus k is y plus 2. We know that the center is h comma k, and our radius is r. So let us try to solve this equation here. We can subtract x from both sides, which will give us minus h equals minus 4. So you multiply by minus 1 on both sides, here and here. You get h equals 4. Same thing here, you have y minus k equals y plus 2. You subtract y from both sides, which gives you minus k equals 2. You multiply by minus 1 on both sides. Then you have minus k times minus 1 equals 2 times minus 1, which is k equals negative 2. So our center of this equation here is 4 comma minus 2. Now we have to figure out what the radius is. We just compare this here. So we have r squared equals 9. So we have r equals square root of 9, which is 3. We're only considering the positive because it's the distance. So now we have our radius and our center. we can now easily plot our circle. So our radius is 3, our center is 4, comma, minus 2. So on the x-axis, we have 1, 2, 3, 4, that's 4, and minus 2, minus 1, and minus 2. Let me erase this so we don't get confused. That is our center. Then our radius is 3, so 1, 2, 3 on 4 sides. 1, 2, 3 here, 2, 3 here, 1, 2, 3 here. And then we join it. So here, our center is 4, comma, minus 2. And our radius r is 3 units. Okay, let's do another example. Here you see that the signs are a little bit flipped. This is just to get a little practice of making sure that we don't make small mistakes where we do not take into consideration the signs of h, comma, k. Okay, let us again write our formula, which is x minus h whole square plus y minus k whole square equals r squared. Then we write down x plus 5 whole square plus y minus 1 whole square equals 18. Again, comparing, we have x, we have, oh my God, okay, all good. So we have x minus h equals x plus 5. Subtracting x on both sides, we have h minus h equals 5. Multiplying on both sides by minus 1, you get h equals minus 5. Similarly, we have y minus k equals y minus 1 here. Subtract y on both sides, and then you get minus k is minus 1. Multiply by negative 1 on both sides, you get k equals 1. So our center, which is h, comma, k, is minus 5, comma, 1. And our radius here is r square is 18. So r is root 18. I would suspect that it is a little bit over 4. Let me find the exact answer from the calculator. Yeah, it is 4.24. So our radius is 4.24. Let us plot it. We have 1, 2, 3, 4, 5. That's negative 5 here and negative 1. Oh, sorry, it's negative 5 and 1. So that's going to be here. And the radius is 4.24. So it's 1, 2, 3, 4 and a little bit. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, and 4 here. And we just join all our points. And that is our circle with radius minus 5, comma 1. Sorry, with the center minus 5, comma 1 and the radius, which is 4.24 units. Okay. So here we're given, write the equation of the circle with the center at minus 2, comma 5 and a radius of 6. So here basically we're given all the information we need to plot it. We have, so let us just plot it because we have all the information. We have negative 2 here and 1, 2, 3, 4, 5. That's our center. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. And then we join it. So that's our center, which is minus 2, comma 5. And it has a radius of 6. So let us try to write the formula again. We have x squared. Not this, the standard form, x minus h whole square is y minus k whole square equals r squared. So we are given our h, comma k is minus 2, comma 5 and our radius is 6. So h is minus 2. So wherever we see a h, we put minus 2. That's whole square. Plus we have y minus k, which is 5. And then we do whole square equals r, which is 6. And now we have 6 squared. Simplifying this a little bit, we have x plus 2 whole square plus y minus 5 whole square is 6 are 36. So that is our circle equation where the center is minus 2 comma 5 and the radius is 6. Okay. We have a couple of more examples here. We are finding the center and the radius of a circle, and then we are graphing it, and this is the equation. As you see here, it is the expanded equation, and this is something that we learn, I think, when we are completing the square. I think I have 2 problems here, and we'll quickly do it. Let me first again begin with our standard form of the circle, which is x minus h whole square plus y minus k whole square equals r square, where h comma k is our center and r is the radius. When we expand, there is this handy formula for expansion. It's a plus b whole square is a square plus b square plus 2ab, and a minus b whole square is a square minus 2ab plus b square. We will be using this second one because we have the negative sign in between. Let us now expand this. So you'll get x squared minus 2xh plus h squared and plus y squared minus 2ky plus k squared equals r squared. Now let us write down our formula. Let's put things down wherever they are, and then we will go to the next step. So here we have x squared. We have a y squared. We have plus y squared. We have a plus 6x. We have a plus 4y. And what I usually do is if there's any constants like 12 here, I just send it to the other side. So here we have minus 12. Yes, I'm thinking maybe you were thinking that why am I having minus 12 under r squared, but everything will make sense slowly. So let us try to fill in these gaps. So here, as you see, we need something here and something here, and definitely something here to make this a positive number, right? So let us again compare term by term. So this term is this, here, here, here. As you see, x squared is x squared, so we are good with this. The next one here, we have minus 2xh equals 6x. So here we're trying to find what h is, right? So h is 6x by negative 2x. You cancel both the x's and then you get minus 3. So our h is minus 3. Similarly, we do the same thing for our k here. We have minus 2ky as 4y. So you cancel the y's, then you have k equals 4 divided by minus 2, which is minus 2. So h is minus 3 and k is minus 2. Yep. So now we can write this thing here as x squared minus 2x. We have our h, which is minus 3, plus h squared, which is minus 3 whole square. Then we have y squared. Then we have minus 2k Not k, we know what k is now. So what is k? We have -2. Then we have our y. And we have plus k squared, which is -2 whole square. Now, one thing to notice here is we added these two numbers. Whoops. We added this and this to our left-hand side. So since we added to the left-hand side, we have to make sure that we add it to the right-hand side as well. So here we have -3 whole square, which is 9. So you add a +9. And then you added a -2 whole square, which is 4. So you add a 4 here. Let me erase this for now so we have some space. And let us write this down in a nicer way. Oh, one thing to note before we forget is we got our h, which is -3, and k, which is -2. Let us put this on the side and continue here. So we have x squared plus 6x plus 9 is y squared plus 4y plus 4 equals -12 plus 13 is 1. Now we can compare our r squared with the 1. So here we have r squared equals 1. So r is √1, which is again 1 unit. So we got our h and the k, and we got our r. So our h is basically the x-axis here. So 1, 2, this is -3, and we have 1, 2, -2. We have a really, really small circle here, which is of the radius 1. That is our circle. Okay, let's move on here. If you look clearly, the difference between this equation and this is that here x squared and y squared have no coefficients, but here you see x squared and y squared have coefficients. So now we will see how to deal with equations where x and y have coefficients. The first step would be, again, writing down our formula, the expanded one, which is x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared equals r squared. Okay, the first step I would do is take 4 common out of this whole thing here. So let us give this thing a pause, and we rewrite this in the form x squared plus y squared plus 8 by 4x minus 16 by 4y plus 11 by 4 equals 0. So here we have 4x squared by 4 and 4y squared by 4. And if we simplify this, we get x squared plus y squared plus 2x minus 4y plus 11 by 4 equals 0. Now, let us write this down under our formula. We have our x squared, we have our y squared, we have our plus 2x, we have our minus 4y, and here we have minus 11 by 4. So again, we need to fill up this part and this part here. So the whole reason for us doing this is to make sure we don't have to compare the 4x squared with x squared. That would be a bigger trouble. It would just get complicated for kind of no reason. So instead, you just do it in your first step itself, just making things simpler. Then the only fraction you would most probably have is with the constant here, and just doing the subtraction and addition with fractions is much more easier when you don't have letters involved. So now let's repeat the same process where we are comparing term by term. So let us get what h is. So minus 2hx is 2x. So x gets canceled on both sides. You have h equals -1. Similarly, we do the other one, which is minus 2ky equals -4y. Cancel y's on both sides, cancel the negatives on both sides. So k is 2. So we got our center, which is h comma k. It's -1 and 2. Okay, so let us now fill in our blanks here. So we have plus h square, which is just 1, and y square, k square is 2 square, which is 4. Since we added +1 and +4 on the left, we have to add the +5, basically +1 and +4 onto our right. So this is -11 plus 4 plus 16 by 4, which is -11 plus 20 by 4, which is 9 by 4. So here we have r square as 9 by 4. So r is root of 9 by 4, which is 3 by 2 units, which is 1.5. So now to write the equation in a much more compact way, that would just be x minus h, which is -1. So that becomes, so this plus y minus k, our k was 2. So y minus 2 whole square equals r square, which is 9 by 4. So this is our equation. Let us try to plot it now. We have -1 and 2. And then we have 1.5. That's 1.5. And we join all the points. That is our circle with the radius this, and our center that, and our radius is 1.5. Perfect. Okay, so that is the end about circles. In the next video, I will talk about domain and ranges of different functions. Until then, keep practicing, and I will see you in the next video.